Okay, so now we want to do this integral. All right, so let's first sketch what this region is going to be. So let me graph the xy plane, or sketch the little xy plane here, and plot these points. Okay, so these are the three different points, just plotted these points. And now, if you've done a few of these problems, you know that we're going to need to have an expression for each one of these lines. Okay, so for example, this line right here is y is equal to 1. So the horizontal line y is equal to 1. And for this line right here, the slope is 1 and the y-intercept is 1. So that means that the formula for this line is y is equal to x plus 1. And then for this line right here, the slope minus 1/3, and by plugging in one of the points, you can tell that the y-intercept is 7/3. So the equation for this line is y is equal to minus 1/3 x plus 7/3. Okay, and I'm just gonna make this a little bit smaller. And anticipating this switch the order of integration, we know we're going to need to have x in terms of y. So I'm going to solve this for x in terms of y, and when you do that, you get, so this gives x is equal to minus 3y plus 7. Okay, so let's do the integral in the y. If we do the y integral first, let's look at what happens. So if we do the y integral first, this means that for every fixed value of y, we're going to start at the line y is equal to 1. But notice that when we are to the left of this blue line, y is going to go from y is equal to 1 to y is equal to x plus 1. And when we're to the right of this blue line, y is going to go from y is equal to 1 to y is equal to minus x plus 3 over 7. So we're going to have to split this into two integrals. So the first integral is going to go from x is equal to 0 to this point. Now the x value here is going to be the x coordinate of where these two lines intersect. In other words, where x plus 1 is equal to minus x plus 7 divided by 3. And that's going to be x is equal to 1. Okay, the inner y integral for this one, y is going to go from 1 from this bottom boundary up to this top boundary, which is x plus 1. Okay, the function that we're integrating is 7y squared dy dx, and now we're going to have to add the integral for the other part. So at this point, x is going to go from 1 to this point, so it's going to go from this point to this point. X is 1 here, x is 4 here, so this is x equals 1 to 4. And now the y integral is going to go from 1 to this, minus x plus 7 over 3. So this is minus x plus 7 over 3. And then this is 7y squared. Sorry, that's a dy up at the top. dy dx. Okay, so now we're going to do the x integral on the inside. Okay, now the x integral is better because when we do the x integral, for every fixed value of y, we're going to go from this line, y is equal to x plus 1, to this line, which is y is equal to minus x plus 7 over 3. So it's going to be, no matter what y is, we're going to have the same x bounds. On the inside, is going to go from the line y equals x plus 1 to the line y is equal to minus x plus 7 over 3. So the bottom limit is going to be x is equal to y minus 1, because if y is equal to x plus 1, then x is equal to y minus 1. And the rightmost limit is going to be minus 3, that's a 3y plus 7 plus 7. That's just this line, y equals minus x plus 7 over 3, solve for x. And then y will go from 1. It's going to go from 1, y is equal to 1, up to this point. The coordinates of this point are 1, 2. And I just realized that when I did the blue integral, I solved an algebraic problem to figure out what the intersection of these two lines are, but silly me, we were given what that coordinate was. So I just did a bunch of extra work because I wasn't paying attention. So let that be a lesson. Always pay attention to what you're given. Don't do like I did. Learn from my mistakes. It's always better to learn from my mistakes than it is to learn from your mistakes. Okay, and so that is the same integral but in red. I mean, but with the x integral on the inside. So the right integral is clearly an easier integral to do than the blue integral. Okay, now we come to this problem. So the first thing that I'm going to do is sketch this region. So we know x goes from 0 to 1, and y goes from 0 to x squared. So the left x limit is going to be x is equal to 0. The right x limit is going to be x is equal to 1. And then the y limit is going to be 0 to x squared. So it's going to be something like this, okay? And then so the region that we want is this, again, it's like this parabolic triangle. I don't know. I just made that term up. I don't know if that's an actual term, but it's kind of like a triangle where one side is a parabola. Okay, now if we do it with the y integral on the inside first, we know that y, we're integrating in this direction. So y is going to go from 0 to x squared, and x is going to go from this point to this point. We know x is going to go from 0 to 1. So this is x is equal to 0 to 1, and we're going to integrate the function 5y divided by 6x to the power of 5 plus 1, and then it's going to be dy dx. That's if we do the y integral on the inside. Okay, now if we do the x integral on the inside, well, for every fixed value of y, we're going to integrate this way, from the parabola to the vertical line. So the x limits are going to go from y is equal to the square root of y to 1. The vertical line is x is equal to 1. And then the y values are going to go from 0 up to 1. Okay, why does y go from 0 to 1? Well, the 0, I think, is kind of obvious. Y is going to go from, this 0 up to this point. Well, this point is where the parabola y equals x squared intersects x is equal to 1. So in other words, the x coordinate is going to be 1. So that means the y coordinate is going to be 1 because y is equal to x squared. And then we'll have 5y divided by 6x to the power of 5 plus 1 dx dy. Okay, now again, these are both the same integral in the sense that they're both integrating the same function over the same region. But if we just look at it in the blue integral, when we do the y integral, well, the antiderivative of y is going to be 1/2 y squared. So when we plug in this x squared, we're going to end up with x to the power of 4, which is going to help us do a u substitution in the bottom here. We can do a u substitution and say that u is equal to 6x plus 5 over 1. Okay, or sorry, u is equal to 6x plus 5. Now over here, if we do the x integral first, we're going to end up with something a lot more difficult to do, because we're going to have to find the integral of 1 over 6x to the 5th plus 1, and that's just going to be something irritating. So clearly, in this case, the blue integral is the easier one to do, and I will leave you to do that. After you recognize that the blue integral is the easier one to do, it's a straightforward integral to do, which does not mean it's an easy integral.